page 17. We're gonna start stating the maximum and minimum amounts. That's today's theme, right? But we're still building on what we learned before. Once you state a measurement plus or minus the uncertainty, where did you get your uncertainty from? You needed to figure out the precision first and foremost, right? So always remember that. We're actually saying that a measurement can be above or below, right? There could be a maximum or a minimum amount possible. The target, right? So in general, when you have the measurement plus or minus uncertainty, watch this. I'm gonna highlight max with orange and you're just gonna make sure you add the measurement and the uncertainty. And if you want to figure out the minimum amount that could possibly be there, then you just got to make sure you subtract. You go measurement minus uncertainty. Okay, let's put this to the test, right? Let's see how this works. Can you see well, guys? It's not too bright. We're good? We're good? Okay. And you're following, right? So the thermostat in Mr. D's classroom is set to 72 degrees. So obviously it's right there and it's Fahrenheit, right? We know the unit. State this measurement plus or minus its uncertainty. So can I say something? Let's say this question had no picture whatsoever like that. You just go by the number. You always go by the number. But if there's a picture at all, you need to go by what's on that picture. You got it, guys? The picture wins, right? So in this case, the picture doesn't tell you a whole lot of information. It just says that in this room, it's set to 72 degrees. And by the looks of it, it could be that the temperature could go up to 73. It could go down to 71, right? So basically, the precision of this, where am I going to do it? Here. The precision of this thermostat right here is 1 degree Fahrenheit, okay? Which means that the uncertainty is 1 divided by 2, which is plus or minus 0.5 degrees Fahrenheit. You are allowed to do that if you need to. You can just turn a fraction into a decimal. And so this is kind of like the prep work you need to do. Almost anything you do will take you back to finding the precision and then figuring out the uncertainty. Okay, so let's do what it's asking us to do. The measurement is actually, there's no guessing, it's 72 degrees. So we'll go 72 degrees Fahrenheit plus or minus, what is it asking for? The uncertainty. So you grab that and you just say, hey, this is what this question is asking me to do. Every time you buy a bottle of pop, like this Fanta right here, can I use that for a second? What does it say on there? How many? 500 milliliters. You think there's actually 500 in here? Could be more or could be less, right? Because the machines, like there's always a little bit of leeway, and it's because the machine is limited. It can be pretty precise, but not all the time. So basically, I'm going to say it's 500 milliliters plus or minus 1 milliliter. Maybe more, but for our purposes in this course, that's what we would treat it as, right? So this then gives you what we call a maximum and a minimum temperature and possible in this room. So to get the max, you guessed it, you go 72 plus uncertainty at 72.5 degrees Fahrenheit. And the lowest or the minimum temperature that could actually be in the room is 72 minus 0.5. So that's 71.5 degrees Fahrenheit. So you're saying, hey, I set the temperature to 72, but in actuality, in this room, it could be 71.5 or it could be 72.5. It could be anywhere in between. So keep that in mind. Okay. So the highest possible, lowest possible temperature based on this reading right here. Okay. So using this knowledge right here, Mr. D has plants in the room that need a room temperature of at least 65 degrees Fahrenheit. At least. So it could be higher, but it cannot be lower. What would it be a good idea to set the thermostat to exactly 65 degrees? And the answer would be no. No, it wouldn't be, because I will just say this. No, it would not. Not be a good idea. Since we need to consider the uncertainty of the thermostat, of the measurement on the thermostat. This is the key word, the uncertainty. It's not a good idea because there's some uncertainty. So for example, if you read 65 on the thermostat, we're using the same thermostat, correct? So technically, it should still be off by the same amount, right? If you set it, if I go there and go arrow down to 65, the uncertainty stays the same, right? So it could be the highest temperature in the room could be 65.5, and the minimum could be 64.5, right? And this is a problem, right? Too cold. And you're like, Mr. Dirksen, it's just 0.5. It's just 0.5. Big deal. The plants will make it. You're missing the point right now, right? We're just focusing on this. Like, if we're going to be so picky with the uncertainty, we need to, right, consider it and just realize that's too cold. Because of the uncertainty, right? Because of the uncertainty, when we read 65, we're actually not reading 65. It could be 65 plus or minus 0.5. Scratch, scratch. Where did we get the 0.5 from again? All the way up by first finding the precision and then splitting it in half. Okay. Okay. So if you have your fridge, right, and you don't want your items to spoil, the milk, you don't want it to spoil, and you want it to be, minimum, it should have a minimum temperature, can't get any warmer, right? You should consider the uncertainty as well, right? Depending on how your fridge can be set, right? Like my fridge doesn't have degrees, it just has like degrees of how cold it is, right? So we couldn't really apply that. But I know that at a grocery store, they measure their temperatures all the time. When I worked at 7-Eleven, I had a infrared gun, right? I had to open the freezers, the fridges, and constantly, a couple of times a day, record the temperatures in that fridge or freezer, right? To make sure it doesn't spoil. All right. Review how to read a measurement using inches and centimeters. So this would be the metric. This is on page 18, yeah. Metric is just meters, centimeters. the metric system. Do you remember that? I think you do. But what you do anytime, you just count from one number to another number, how many gaps are there if you're not sure, right? So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So every stretch has 10 millimeters, right? Every stretch has 10 millimeters. But you can also say, or from here to here is 1 centimeter, right? So you could use either method, okay? So watch this. Example, if something measures, let's say you measure and something is 4.5 centimeters. Let's mark this. 4.5 would be right forward, and you just measure 1, 2, 3, 4, 5 is right there. That would be 4.5 centimeters. If you multiply this by 10, you get 45 millimeters. Either one is acceptable. They're both saying the exact same thing. I know you remember this. I just want to make sure we're all on the same page. The precision, if you read this, you don't go by the numbers here, you go by the ruler. Go by the picture. Okay? So we would say 1 millimeter is the precision. Uncertainty is plus or minus half of a millimeter. Please box this in and say used picture for that. Sorry, I have to zoom out a little bit. I use the picture. Picture always wins the contest, right? So if there is some sort of picture of the device that has been used, right, then we go by it. Okay. Does high minus low divided by number of gaps? Some of you remember that if you watch the video. It works here, but I'm not going to show you because it's too basic. It's always 10 for us, a metric ruler. Let's go back to imperial system. You know what? I'm going to stick with inches. I'm not going to go feet necessarily. I'm just going to stick with inches here. But it could be that from here to here you have a big number. So let's say this is 3 inches and this is 4 inches, right? So from here to here it's an inch, right? Let's figure out the precision. This is especially true for the imperial system. You just go from mark to mark. So 1, 2, 3, 4, 5, 6, 7, 8. This is precise to 1/8 of an inch. Okay? The uncertainty of this ruler that is being used right here, or measuring tape, what's half of 1/8 as a fraction? 1/16. 1/16 of an inch, plus or minus. And you're like, Mr. Dixon, I hate fractions. Just figure out the 8 gaps, right? The 8, you counted 8 from inch to inch. You counted 8, right? Just go like this, 1 divided by 8. That's 0.125 of an inch. Divide that by 2. Divide this by 2, you get that. So if you like to stick with decimals, I am okay with that. Watch, 1 divided by 16 is that number. So I'm going to put an arrow here and just divide that by 2. Even though I would like you to know that when you divide something in half, especially a fraction, you actually double the denominator. Okay, you're taking 1/8 of a slice and you're slicing that in half, so you're actually doubling the sections on that piece of pie or pizza or whatever you want to call it, right? Next, let's change these numbers. Let's say you're going from 6 inches to 7 inches, right? Just to tell you, this is somewhere down the line. Same thing, right? 1, 2, 3, 4, 5, 6, 7, 8. I don't know why I added this, and I actually do know now. I didn't mean for this to happen, but it did happen. So just copy this. I actually wanted to, once you wrote this down, I'm just going to show you because I think it's still good to use. This is what I actually wanted to do here. What's the precision of this top one if I had done this? Oh, wait. So then you would count like this. 1, 2, 3, 4. This is the precision of this modified ruler is now a quarter. So this would have been 1 over 4, and the uncertainty would have been 1 over 8. Works the same way. So if you take it with me again next year, come back, this booklet will be cleaned up and fixed. Why would you do that, right? No, I'm just joking. Anyways, what about this one here? What's the precision and uncertainty of this ruler here? Let's put, I don't know, let's make this 8 and this is 9, right? So from 8 inches to 9 inches, that's what we're zooming into. So you're like, whoa, there's a lot of stuff going on here. Some of you see the precision already, but just don't despair. Just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It is a 16th of an inch. That's the precision. Therefore, my uncertainty will be 2 times 16, 32, right? 1/32 of an inch. It's pretty precise, this thing. This one is quite precise, right? So I wanted it to be a quarter, then I wanted it to be an eighth, then a 16th. This would be the most precise, right? And if you don't believe me, 1 divided by 16 is 0.0625 of an inch. If you take 0.0625 and divide it by 2, you get this, plus or minus, right? Forgot to put the plus or minus, even though I'm not going to take off marks if you don't have the plus or minus. It does need to be when it's measurement plus or minus the uncertainty, then you do need it, but not here. So don't be scared of the imperial rulers. I will have them on quite often. So just remember what I taught you here, right? Okay, let's measure some stuff. Let's go to page 19 here. Page 19. I'm going to do a lot of pictures. So you go by the picture. Okay, got it? Before we measure, let's figure out the precision and the uncertainty of this ruler. It's metric and it's got the small little lines. What is it? 1 millimeter. All right? The uncertainty is plus or minus 0.5 of a millimeter. Based on picture. Based on picture. I will give you some wacky rulers, guys. I get very creative. So just make sure you understand. I did technically count from any centimeter to another. I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 1/10 of a centimeter, which is a millimeter though, right? So what's the measurement of this thing? You have to take the closest one to it. So watch what I do here. I'm going to zoom into that. Stay focused here. There we go. I do this on purpose. Sometimes when I print it, it's off even more. but this one is closest to this line here, right? So that is 3.8, right? So I'm going to say that that's 3.8 centimeters, or if you multiply this by 10, it's 38 millimeters. It's up to you which one you want to use. So you had to pick which one it was closest to. So let's state the measurement. For A, it's 38. I'm going to stick with millimeters. 38 millimeters plus or minus 0.5 of a millimeter. I got this from the work I did before, right? Just watch out. Sometimes this line, this bar that we're measuring, is not right at the 0 line. It might start at 2 or something like that. So you need to watch out for that, okay? Don't count from 0 if that's the case. So there we have our measurement plus or minus uncertainty. Let me focus again. So this, you can do it. You can do it. There you go. This part is right here. Can I say something? I just don't want to have it in my notes. It's okay to say 3.8 centimeters plus or minus 0.5 millimeters. It's okay to have different units. Okay, as long as you put the units down. So no rounding, and make sure units are always there in this particular unit. Now they want the minimum and the maximum. Max is 38 plus 0.5, so that's 38.5 of a millimeter. The minimum is 38 minus 0.5, which is 37.5 millimeters. So this piece that we just measured, when we give somebody the measurement, they would have to assume that it's either 38.5 or 37.5. And that's because there's a limitation to the device that has been used. You had to pick which one it was closer to, all right? Sometimes it's very obvious, sometimes it's not that obvious. Maybe let's go arrow from this 0.5 here. Just going to show you that's where I got that from. Okay. And there we have our max and our min. Okay. Okay, we're doing good with time. Let's try this one here. B. Let's figure out what the precision and uncertainty is of this thing. So I don't know. I feel like I'm going to do this here. Precision and uncertainty like that. So you go from inch to inch. So you just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Got it? So we now determined that 1/16 of an inch is my precision, and therefore the uncertainty is half of that, plus or minus of an inch. And you're like, I can't do fractions. That's fine. And I forgot already what the numbers are. 0.0625 of an inch. This is 0.03125 of an inch. So here's where you have to be okay reading your measuring tape, right? So this actually, which one would you say this is closer to? Would you say this or this? more to, if it's that close, I'm not going to take marks off. Okay, I'm just going to say it's closest to 1.5. Maybe my eyes are deceiving me, but this is half an inch right here. It's midline. So this would be 1/16, 2/16, 3/16, 4/16, 5/16, 7, 8. No, not 8. This would 7/16. Sorry, this is a 7/16. I know this is 8/16 because that's half. So I'll do this. 1 and a half, right? Plus or minus 1/32 of an inch. Or 1, was it 7/16? Yeah, I said 1/7/16, right? Of an inch, plus or minus 1/32 of an inch. Because this one is wishy-washy, I would give it, is that even a word? I don't know. I just threw it into my lesson. There it is. So either one would be fine. Either one would be fine. So let's get our max and our min. And here's where you need to be good with fractions. You want me to give you the I'll do no fractions. So here it is. 1.5 inch plus or minus 0.03125. I'm going to go with this one here. And so my max is, if I add it, it's 1.53125 of an inch. And the min, you just subtract them. I have that already. So you go 1.5 minus this, which is 1.46875 of an inch. Do not round, okay? This is a bit of a pain, I know. It's if I could, I would use centimeters, but you need to be comfortable with both. Yeah, you need to be comfortable with both. It's just going to be a matter of practice. Can you figure out? I want you to use this example, figure out the precision and the uncertainty based on what you see here. And then I want you to measure this thing, right? State the measurement plus or minus the uncertainty of this, okay? And then max and min will do it together, but try to figure that out. What would you say is the precision and the uncertainty of that? There. So to me, honestly, getting your precision and uncertainty is like the first step for almost everything we do. So you can tell that this is going up by 10 centimeters at a time. So the precision is 10 centimeters. Your uncertainty is therefore plus or minus half of 10, right? There we go. You got that out of the way. Now let's measure this thing. What is it closest to between the two here? It's closer to 20, right? So you gotta, it's okay. You gotta pick 20 centimeters and then just go plus or minus whatever you determined as being the uncertainty. I know it's kind of counterintuitive because some of you would have just been like, Mr. Dirksen, this looks like an 18 centimeters to me. Don't do that. Not in this unit. Don't do it, right? Just go by what's there. If I had put a mark in between here, then we're assuming this would have been 15, right? And so forth, but there's nothing. So just leave it. It's just to emphasize the point, right? So this is it. So we get a max of 20 plus 5, which is 25 centimeters. I know. It's more of a concept than necessarily what's happening. Yeah. And I did this because on an exam, the province had made this thing went up by 3 centimeters, and students were like, they were just doing what makes sense, right? It's like, oh, this looks like 18, so just put down what made sense, but just got to go with the concept when you're in this unit, right? Okay, so this is the measurement plus or minus uncertainty, and from here we get our max and our min. Okay, it all started with precision and uncertainty, though. It all started there. Then we measure, then we find max min. Okay. All right, come with me. One more, and then I'll let you try some on your own. You need to try. You need to try. State the measurement like this. Based on this measurement here, guys, does it say Celsius or something? It doesn't, eh? I'm assuming this is Celsius, or else it would be very cold in that room. Okay, 22 Fahrenheit, you'd be freezing. Okay, so let's put Celsius at the top. And based on this number, I am assuming, I don't know, I can't press, right? Let's try pressing that. I don't know what it's going up or down by. Stop finding Mr. Dirksen. Anyways, 22.4 would be assumed that it would go down by 0.1. And if it's any warmer in this room, we're assuming it's 22.6, right? We're going up and down by 0.1. So let's put this right next to the picture. 0.1 degrees Celsius is my precision. And therefore, half of this, if you divide that by 2, you get 0.05 degrees Celsius. In this case, following the picture or following the number would give you the same results. So this is important. Let's box that in. So the measurement of this room is 22.5 degrees Celsius plus or minus 0.05 degrees Celsius. That is what they wanted. That's all that you're being asked to do here. It all started with figuring out the precision and then figuring out from that precision what the uncertainty is. Okay, so I don't know if you want to highlight maybe just this piece here. How did I get that? Well, it came from here. Okay, and now that you have the plus or minus, you can figure out the max and the min. Right, so 22.5 plus 0.05, and the min is 20. At this point, whatever you got in A, you just follow this formula, right? You go plus, minus. You can still score marks here on a quiz, AC, whatever. So 22.5 plus 0.05, that'd be 22.55, which is weird, right? But it's still, that's just how you do it. You just have to be very careful with decimal places, right? Like some of you just, oh, just take away 0.5, so it's 22. It's like, no. This is technically 22.50, and you're taking away 0.05, right? You're taking away 5 from 50, which gets you the 45. So you got to be careful there. I feel like before I completely let you go freely, I want you to figure out the precision and the uncertainty of this thermostat right here. Just do it. And if you need to consult with your neighbor, do it. But just as quietly as you can. What would be the precision and the uncertainty? That's okay. Such a weird unit, right? If you want to add something to your study sheet, I would say, right? This is for pictures, right? If you want to get your precision from a picture, then this is a good formula to use. So what does that mean, high and low? You look for the numbers that are there. So let's say you pick 60 and 70. So this is your low and this is your high, right? So you basically go over here and you say, hey, I'm having this picture and I need to know what each mark represents. Like how much am I going up by? So watch. 1, 2, 3, 4, 5. I took 5 steps to go from one number to the other. Those are what I call gaps. So you go high minus low divided by the number of gaps, and that is 5. So 70 minus 60, quite often you can do it in your head, right? 10 divided by 5 is 2. So in this case, what's the unit? Does it say it on there? But if you know anything about temperatures, it would have to be Fahrenheit. Okay. So your precision is 2 Fahrenheit from the picture, right? There are 5 gaps. 5 gaps from one number to another. Okay. So each time you go up, it represents 2 degrees. So from that, I'm going to state my uncertainty, which is half of that, right? 2 divided by 2, which is plus or minus 1 degree Fahrenheit. This should actually be boxed in like this. Now I can state my measurement. I don't know if you noticed, but this right here tells you what the temperature is. Or down here, it's up to you. It's actually 72, right? Because it's on the first mark past 70. And I know that every mark represents 2 degrees. So it's 72 degrees Fahrenheit plus or minus 1 degree Fahrenheit. This is what the question wants. So now I can get my max. This is so easy, you don't even need to show work on this one, but I will. Right, max is 72 plus 1, which is 73 degrees Fahrenheit. Hmm, 72 minus 1 is 71 degrees Fahrenheit. Just make sure when you do these questions, some students do this. They just give me that. Please tell me we need to know which one you think is the max and which one you think is the min. So just label it, right? I'm okay with you not showing the work. It's the risk you're taking, right? But make sure you tell me which one is max, which one is min. Because I do know, but do you know, right? That's what they want to know. This one is controversial to a certain degree. See what I did there? To a certain degree. There's Fahrenheit on one hand, and there's Celsius on the other hand. So I want you to do it for both of them. So pretend like the Celsius is gone for a bit, like that, and then just figure out the precision and uncertainty for Fahrenheit, and then state the measurement plus or minus its uncertainty, and then get rid of Fahrenheit and just do the Celsius side. Use this space here, guys. I had to use this space. I kind of miscalculated. If you need to do any kind of math, use that as well. Okay? Yeah, so your responsibility is all the way to page 24. Okay? Lots of pictures. I will post the key as soon as I scanned it. So all the way to page 24. I'm mixing up pictures and just numbers, right? So I'm going to leave it at that for now. That's your homework. I will write it down here at the bottom. Homework, pages 20 to 24. That's it. You